talking about data frames in depth, and I will be looking into subsetting, filtering, grouping, and then some Boolean operations with join operations that I discussed last time. And the today in today's class I'll be using Jupyter notebooks because I'm planning to give this one as a note, so it'll be easy for me to run with Jupyter notebooks. The same thing applies in the VS Code as well if you are using VS Code. So just in case, okay. So I'll start from the beginning itself, going into I'll close everything. Okay, so when you want to start Jupyter Notebook from a specific folder, now for instance, I'm using this folder, which is UOM S5, this data wrangling files. So make sure that you don't have spaces in the name. Like here, I specifically change the name with underscore because I want to get into the folder, and in Python, it's a bit difficult when you have spaces in the names. So what I'm going to do is I'm going to open up my Anaconda prompt, and then you can see the environment is base. So if I run Jupyter Notebook from here, if you run it from here, it will be run with the folder, run in the folder where it's in the local host is created in the documents folder. So this is not what I want. I want to create it inside the folder that I have my files. So in order to do that, what we can do is, while opening the Jupyter notebook, you need to type. So this is the base. So you can type uh, Jupyter notebook. Now you need to give the notebook directory. Notebook directory is equal to this file path. So if you give this Jupyter notebook, then you have two minus signs, notebook minus sign directory equals where the files are, and when you enter it, it will run from that particular directory. So you can see the folder files there. If you see that, now you can see the files because I have changed the directory where the Jupyter notebook has been opened. So you may have different files taken from other sources like GitHub or other places. As such, even for this class, you may be downloading IPy NB books, these notebooks, IPy notebooks, and other Python exercise files, etc. Maybe you are keeping in a separate folder. So you can open your notebook from there if you just give the directory name Jupyter notebook, then dash dash notebook dash directory equals the path, right? So first of all, let's go to the um, explanations here. Start from the basics. So this is a book, a deep dive into data wrangling with Python. That's one of the latest books. In previous chapter, we learned how to pandas, NumPy, and matplotlib. So we discuss about them with NumPy arrays. So today's discussion is about subsetting, filtering, and grouping. One of the most important aspects of data wrangling is to curate the data carefully from the deluge of streaming data that pours into organization or business. You can skip that part. So we'll go to the exercise directly. I'll anyway give you the book extraction, so don't worry about it. But the file folder is here. So for you to download it, let me upload it to the Moodle. I'll upload the Excel file to the Moodle so that you can download it from here. So just log into your Moodle. Data wrangling. Today's class. Have I uploaded the recording? I forgot. It's there. maybe I have uploaded it, I don't know. So let's turn editing on. And for 23rd May 28th, so this, so fully okay, not shown because this is hidden. Okay, just in case, let's remove them because I'm not really keen on opening them yet. Okay, just take the superstore data from here. Let's go back. So let's start the proceedings with whatever given here. You can install the pip commands from typical Jupyter Notebook environment. I'm going to create a new file and name it today's name, class date 29th. Okay. You can name as you like. I'm going to upload it here. Right, let's start from the book. So if you haven't installed XLRD, that is for reading Excel files, to read an Excel file into Pandas, you'll need a small package called XLRD to be installed on your system. Use the following code to install the XLRD package. So I don't think that I need it because when we install Jupyter Notebook, typically this is installed as far as I know. So let's try to run this command and see whether um, it's there. So let me just copy this code and see whether it's, yes, come, see whether it's uploaded, whether it's imported into the system, which is easy for us to then carry on from there. NumPy, pandas, matplotlib, everything is there. Then let's read pd read excel. Now I am in the working folder. I don't need to specify the specific name. Instead I can just write the name like this and it should be there. That's because of the name. Let's see. Come on. So they're asking me to install XLRD, so I'm going to install it anyway. I'm going to use it, install in the Conda environment. I can do it from here or I can run it from here using pip command XLRD. This particular exclamation mark in front of this tells the Jupyter Notebook that it's not a usual Python command. It means it's a pip command that is run on the Anaconda prompt. Should work. Otherwise, you can, if you don't put this exclamation mark in front of this pip command, it will not work. For example, if I just say pip, it will not work. Should not work. Okay, it works. Stranger things happen. Anyway, so pip command should be run with the exclamation mark. That's how it should be. Then we'll go to, now it should work from here. Now it says, I have already installed. Just install it in the Conda environment. If it doesn't work, you have to install it Conda environment. Better to run it as the administrator. Conda install XLRD. Until it resolves. So now the base environment has the Anaconda distribution of XLRD. That should work by now. Let's see. So it works, right? Now, so basically, if you get an error, just read what it is and then follow up. So if you are using VS Code, make sure that you are installing pip in the VS Code. Like now, when I run pip installs the XLRD function, XLRD package in the environment that was specified. So if you're running with VS Code, you have to install in the Conda environment that you you need to go to environments, Conda environment info. Sorry, I think the other way around. Conda info environments. Yes, and then go to data rank, the particular environment that you have created for the VS Code, and then install pip, install the XLRD there. Otherwise, it will not work, because now I run pip and it install the package in the Python directory. Now it didn't work because Anaconda looked at the base packages, like to the base environment. So I had to install using Conda. Now, if you are running with VS Code and you still get this error, that means you have to install it in the environment that you are running your VS Code. So if I want to install it, you have to change the environment, activate the environment. I'm not going to do it here. Activate the environment where you have you run your VS Code and then install the package there. Install XLRD there. Then VS Code will work. Okay, so let's go back. So we have done it, and this df.head will give you the first 5 rows of the data frame. So just type with me and give your comments right up there. So you can start like typing if you are using Jupyter notebooks, you can start with a markdown, or you can give comments with typical commenting form. Like you can give reading the Excel file as a data frame, and then you can give a comment here saying that the taking a look at the first 5 rows of the data frame. So you can give a little comment here as well, like you can go with the triple quotations saying that you need to install the XLRD package to to open the Excel file, right? So everything is there. Now this is DF head. Let's go back to the book. Right. Right, so everything is done. We have read the Excel file from GitHub into Pandas data frame using read Excel method in Pandas. And here we are. So let's see whether the same data source is there. So you can see the row ID here and the index 0, 1, 2, 3, 4. Remember the Python index value starts with 0. So 4 means actually there are 5 rows. And you have the row ID, order date, and the other column names, so on and so forth. There are 21, I think there are 21 columns, but you can't see all the 21 columns as far as I know. Let's see, just count them, because I think there is a little shrinkage here, which means the total number of columns are not shown. Okay, so we have taken this as a data frame. Let's go a bit further. Now, drop this column altogether from the data frame by using drop method. Now, on examining the file, we can see that the first column called row ID, so this one, row ID, is not very useful because we already have a row index on the far left, because we have two index values basically. Now, if you are using the row ID, that's up to you. If you are using the index, that will be easier because Python will be automatically starting the counts from 0. If you are using row ID, sometimes you may have to go with +1 to indicate that the starting value goes all the way from the 1. So sometimes it's very easy and convenient to keep the index values as is and remove the row ID. So to remove the row ID in Excel, what we can do is we can just click on the column and then delete it, or just hide it if it is not required for your analysis. Now here what we do is we have the data frame, so we are going to remove that particular column by dropping it. So I'm going to use the code here, and please write down the comments as you go along, because that will be helpful for you when you are looking at the IPy notebook again in the future when you are doing your assignment work. And I'm going to anyway upload this one to the Moodle with the book. So now write what you are doing here. Now I'm going to just copy paste this, so it says it's there. So on examining the file, we can see that the first column, it doesn't, what's this, uh, row ID. That's because we have already dropped it in the previous case, right? You have to, because now the notebook doesn't know that it has a row ID because we have already dropped it. You have to go from the beginning itself. So we read it from Excel, and then if you run the head, you can see the row ID. Now we can drop it, right? So that's why that's why it gave an error, because when it comes to that stage, we have already dropped the row ID and it doesn't know what row ID there. So that's why it gave an error. Right. Let's go further. Okay. So at this point, we did three important things. We imported the file. The second thing is we looked at the redundancies. Redundancies means we whether now. If you look at redundancy, what redundancy means is redundancy is something that you have as an extra thing. So when it comes to an analysis, redundant data is something that we carry throughout the analysis without any use. So it takes the memory, it takes the space in the screens. So you can remove them because they are not needed. So row ID was a redundant data column, so we dropped it. So df dot drop row ID axis 1 along the vertical axis, sorry, yeah, horizontal is 0 and along the vertical axis, and in place true means you just drop it. Right, let's go. The output is this and we have the output as this. Right. Okay, let's check the next one. Check the number of rows and columns in the newly created data set. We can easily read it from because we know it was 21 columns, now it should be 20 columns. We can just type the df dot shape. So we have 9994 comma 20 columns, so number of rows and columns. So when you take a data set in pandas, make sure that you first look at the data set from a helicopter view, like looking at the number of columns and the number of rows, because sometimes you can't see. Now even in excel, you are limited by the amount of data that you can see on the screen. So when you open an excel sheet, you may see maybe 20, 30 rows and then maybe around, I don't know, around 10, 15 columns, but the size of the data may be much large. So in that case, you can't see the whole data set. Now in Python, you can look at the shape, you can see the number of rows and columns. And for example, if you know the number of columns and rows in the data set, if you look at the number of null values or say missing values, maybe a repetitive value or something, then you can easily find out how many rows are there that contains null values for a given row, for a given column or given data frame as a whole. So if you know that, you can identify whether the data is usable or not. As I said last time, when we may have large number of rows and large number of columns, but most of the time the available data may not be useful, because they may contain null values and maybe character values that are not numeric. So you can check each and everything one by one if you know the number of data cells present. So we have 9994 times 20 number of cells present in this, so number of data points, right? So let's see. We have now seen that a simple way to remove unwanted columns such as row count. Think about how hard this would be if instead of pandas, list of dictionaries. So in dictionaries, what will happen is, I think I'm not going back to dictionaries. I feel that you are familiar with the Python data structures by now. One of the methods that we use in Python for creating data structures is dictionaries. If you remember, dictionaries contains a unique key value and key value colon value, right? Key value, unique key value colon value. So that's how a dictionary works, and the key values are unique. So therefore, what you could have done, if instead of pandas, you could have done, you can create this as a dictionary and then take the dictionary key values back. So dictionaries are made with the unique key values. So all the values that are related to this will be taken back as unique values. So that's how this could have been done differently with dictionaries, right? We would have right to loop row ID. That's subsetting data frames. Now we have done some work with subsetting. Subsetting involves the extraction of partial database on specific columns and rows. So I I have drawn previously that table which contains, you specifically need a need a column value and a row value. For example, let's say that your index number and the marks for a certain subject. So it's a subsetting. It has some sort of a crossing. So it involves extraction of partial data based on specific columns and rows as per business needs. Let's pretend we are creating a report on our customers at the superstore. Suppose we are interested only in the following information from this data set. We are interested in the customer ID, customer name, city portal code, and sales. For demonstration purposes, let's assume that we are only interested in 5 records, rows from 5 to 9. So if you go back, you can't see the row 5. So we are interested in that. So 5 to 9 we can subset. So it's like you take a little portion out of it, only this much information using a single line of Python code. I'm going to just copy it. I want to do the whole book, so I'm not going to type it. So when you are copy pasting, sometimes the indentation goes off. So make sure that you put the correct indentation. So this, I don't think this has any issues. Let's see. Yes, it doesn't have any issues. So what I did was, I need the row numbers from 5 to 9 for that specific set, customer ID and customer name. I hope you understand it. Like, say you have a birthday cake and you have this happy birthday part and the name, and you avoid those letters and cut a specific part from the cake. So that's what happens. You have the whole data set and you just cut portion of it. That's what we call subsetting. Right. So it goes well um, with the output that is given in the book. Let's carry on further. So we did subset. We need to pass on 2 arguments to the lock method, one for indicating the rows and the other for indicating the columns. So go back and write this. So what we do here, I'm going to type. So look at the data shape, checking the shape of the data frame, right? And here what I want to do is I'm taking a partial fraction of the data frame, and the next thing what I did was going to use the range from row number 5 to 9. Look at in the range command, in range 5 to 10. So you have 5, 6, 7, 8, 9, and 10. So the 10th value is excluded. Start with I range 5 and the last value is excluded. There is no 10. And also remember that in a pandas data frame, you don't have to worry about the first row, because the first row has been identified as the name column value. Right. So for the rows, we have to pass a list, that is, but instead of writing that explicitly, we did this because the columns we are interested in are not continuous, and we cannot just put into continuous range. We have to give them the names, the key names of the columns. So basically, if you want to analyze the data, so if you want to see the data frame separately, like one by one, you can give the column name or range of column names and subset them and see how the data changes from the large scale to the small scale, depending on your requirement. So the second argument is just a simple list with specific column names. So the first argument in subset command is the row number, so row and the column. That's it. Basically, the ith row jth column, if you remember from matrices, ith row jth column goes the same way. I is for the rows and j for the columns. So just give the names. That's it. They said shows the fundamental concepts of the process of subsetting. Let's go. Right. So once we subset it, we can calculate the statistics for the subset. So for example, if it is a particular, say you have, last time we talked about this hierarchical indexing, say that you have one hierarchy that shows For example, semester wise hierarchy. Semester one, you had several subjects. Semester two, you had several subjects, like that. So when you just take it into the data frame, you have the semester, subject, and the marks. So semester, subject, then the marks. So if you want to get semester wise average, or let's say for the first year you need semester one and semester two, then the whole set of subjects, you can subset it by giving the index values here, the row values 1 and 2, and then the column name. So that's what happens here. Df subset, df location, data frame location, I for the range, j for the column name. So if I just type this, so I just say df subset, that's just the name, that's equal to df location lock. So location, I throw jth column. So I'm going to go with the range. The range is I, for I in range 100 to 109, 199. I for I in range 100 to 199. I for I in range 100 to 109. Then the sales and the profit column. I'm interested in that column. That's it. Just the subject, like semester one, then the subject name. So it goes as a list, and I'm interested in sales and profits. Let me increase the size if you can't see it. So it goes sales. You can either type like this and select it and then give the quotation, but make sure that you write it properly. You know that Python is sensitive to the caps lock. And then you go to profit, just select it and then just give that quotation mark and it will work. Right, so what I have done is I have subset the range from 100 to 199, and got that particular level, like semester 1 2, then the two subjects, like that. Then it's like describe. So the describe command works like this. You have the subset or the data frame, then go with describe. Describe. Right, so when you do the describe command, you get a numerical summary, a descriptive summary of all the things related. So you have a count, you have a profit, the mean value, standard deviation, and everything. Why this is important? Can somebody tell me why why getting a numerical summary on a subset would be important? Can somebody tell me why should we take this, particularly in data wrangling? So you have a large data set, you take a subset, and then you sort of describe the data set. Why would you think is important? Have you done deep learning by now? Machine learning? Nothing? No machine learning codes? Right. So what sort of statistical learning techniques have you done by now? I mean, apart from theories, coding, nothing? So when you are doing the description part for a subset, what you expect is to see whether the data set is one thing you can, you remember the five number summary, right? Five number summary. What is five number summary? You have the minimum, maximum, q1, q2, q3, and the outliers that goes. So basically looking at this, you can see whether the data is normally distributed, or what sort of a normalization you are going to apply on this one, what sort of a transformation you think the data is needed. Now, for instance, if you look at the sales and profit data here, you have count 99. So the data, all the 99 rows that we have selected, they contain data. And the other thing is the mean of sales is 265 something, profit is 0.29 something, and the standard deviation is 800 something. For the profit, it's 130.71. So in the minimum case, you have 1.7 and a negative 1,300 something. So the distribution of the two data sets, you can see which one is skewed, which one has a large breadth, and the height of the data. Then if you are planning to normalize them on top of each other to maybe standard normal, or just normalizing with the min max transformation, you can see what sort of a thing to expect. Now for instance, in the case of profit, minimum has a value of negative something. So a negative value, what does it indicate in a profit? It's a loss. So another thing is that we can expect the profit values to go negative. So if you apply, particularly, let's say, log normal transformation, um, yeah, natural logarithmic functions or something, with the negative values, you will not get the correct results, or you will get an error. You have to do the transformation either from starting from the negative value, or you have to remove the negative value so that they contain, say, you need to have some classification whether it's a profit or a loss. Maybe you have to give the labels to negative values as loss, and positive values as a profit. So you have to, you need to look into those things by looking at the numerical summary. So that's why actually these descriptions are important. That the same thing happens here. Right, let's go forward. We simply extract records and run describe function on them, because we don't want to process all the data for this particular business question. We are only interested in sales and profit numbers, and therefore we should not take the easy route and run describe function on all the data. Okay, there's another thing in machine learning. We subset the data for training. So we will, I think when you are doing the practical sessions, you will understand why this subsetting is more important. When you are, have you learned about k-means clustering? K-means clustering? I mean, not in theory, no? So you have to, in order to train, you separate the data sets into separate bins. Like you use those data sets for training. And you know about training and testing, right? 70% training and 30% testing, those kind of things. So like if you use the full data set for the training, what you end up with is uh, high bias. So to remove that, you subset the data set into several columns, like several sets, and then go with 70/30 for each subset. So in that case, you kind of train the model with large number of data sets in the same population. So that's how you subset the data from there. So same thing is important here as well, to see the full data set, but from a subset point of view, to describe a part of the data set, to see how they are spreaded. Now in this case, we can plot it as well, because we have import the matplotlib already. As far as where was it? All right, here. So let's look at the data set. As now we have the data now. I think I have imported pyplot as well. I'm just going to run the subset box plot. This is a 5-number summary. If you remember your probability and statistics class, this is just a 5-number summary. So describe function, box plot, we have the subset function, and then the box plot will show you that 5-number summary for both sales and profits. You can change the visualization, that's up to you, but this is how you look at the data. You can see the profit actually it goes to negative sides. The value there are some losses as well. The values go to negative side, right? Okay, let's go forward from here. As we can see from the preceding box plot, There are some outliers for profit. They could be normal outliers or they could be NAN values. At this point, we can't speculate. You can't see it like you look at the data just from the outset. You take a sample out of it, but this could cause some further analysis to see how we want to treat those outliers in profit. In some cases, outliers are fine, but some predictive modeling, that is for machine learning, regression outliers can have unwanted effects. Now, um, I can't show you here, but because if you have some outliers, say that your model runs like this and that is the most expected model. If you have a segregation of outliers far away from the linear regression itself, these things tend to draw your regression towards them. So you are predicting, sometimes you are predicting like over predicting the actual values because the outliers are dragging the line towards that side. So you have to remove them and you have to understand whether they are outliers or not. So that's why you did statistics in the first semester. I think you did it in the second semester to find out which values are the outliers. You have to drop them. You have to find out by the descriptions. You have to find out which values belong to the outliers and you have to drop them. Like in this case, in the description itself, you have these, say Q1, Q2, Q3 are there, 25%, 50%, and 75% means Q1, Q2, and Q3. Then you have the minimum and maximum values. Then you know, like to 1.5 times Q3 minus Q1 is the range for the actual data distribution. Whatever the value that belongs beyond those ranges belong to the outliers. You have to remove them depending on the analysis that you are going to perform on the data itself. So it is not actually part of data wrangling, but it's part of what you have learned previously. Right. So I'm going to save this one as May 21 part 1. So to minimize any sort of issues when you are referring to them back. Okay. So this is P1. Let's go to the next part. So this is P1 all the way up to looking at the data. Okay, please write down notes here using Python commands like either as comments or as markdowns, however may you like them. So I'm going to make a copy out of it and I'm going to name it as P2 because now from here onwards I'm going to use unique values. I have done everything up to now and let's go back to this. Now the same libraries, NumPy as NP, Pandas and P as PD, Matplotlib as PLT, and then the Excel. I have already read them. So when you look at what is the difference between a set and a list? Can somebody tell me what is the difference between a set and a list? What is the difference between a list and a tuple? Yes, you can't change a tuple. So what is the difference between a list and a set? Exactly. So in a set, you can't. In a dictionary, you can have duplicate values, but the key has to be unique. Okay. So key one may be number two. Key two can be number two, but number two can repeat, but unique values would be there for the indexing. But in a set, you can't have duplicate values. Set is a collection of unique numbers or unique characters or unique elements. So when you look at, say for example, your, like in your case you may have different names. You can have Kasun, you can have I don't know, different names like Saman, different names. So you can repeat the same name again, like you have Amarasuriya repeating several times, you can have Dasanayaka repeating again and again with different names. Disanayakas can repeat, Pereiras, there are so many Pereiras as well. So if you want to have a unique set of values from those things, you have to drop them if you don't want them. So, for example, um, the the context of this comes very important when you are looking at label values. Because say that you have three label values, and if you run the unique, say you already know the shape of the data. Now these are not covered here. The things that I say, they are some practical things that you will observe when you are doing machine learning. So say that you have three label values. So the label 1, label 2, and label 3. You have previously read the shape of the data set, 990 something with 20 columns, right? You said that you read the DF shape, data frame shape. Now, when you run the unique values, you may end up with the number of values that is less than the total number of cells available, or greater. You can't have greater, but you can have some sort of a lesser number, which means there are a set of values that have not been labeled. So you can't use them in the machine learning training, or you have to relabel them. You have to go to the data set and change the labels. Look at the, that we call, I forgot the exact technical term, we call it marking. It differs. The name labeling is the easiest way to remember. You have to relabel. So in the case of state, if you look at df state, I usually type this and then put this. I have to go back. The df df head is there. Let's see. Should work on this. Where was the problem? I have to but I have it already. Okay, I copied this one, right? Okay, I have to run it. This is my copied one. So I'm running it back. This is enough for me, I guess, at the bottom. Right. So instead of unique, if I sort of look at the state, you can see this is US states. So you have Kentucky repeating, California, Florida repeating, California repeating again, but in a different level, a different number of rows. So you have the length, you have the data type, and if you type unique here, what will happen is you drop these repeating values and you have a set of unique values. So this is the unique array. This is very important because to see how many values are there with the unique labels. So for me, looking from a machine learning perspective, the um, the label values, or the string values containing here, they are more or less giving us a label about the data. So Kentucky, if it repeats, that means the particular data set belongs to Kentucky label. So that's how it is. So when you say unique, you get unique set of an array that contains these values, right? Let's move forward. This is what we get. Use the NUN unique method to count the number of unique values in the state column. This is the important part when you are doing the labeling part. As I told, if you have two or three labels, so I'm going to say number unique. N unique means number unique, number of the unique set. So if I copy this and run it here, instead of unique, I'm saying number unique 49. So we have 49 values in the list, unique values in the list. So how many provinces do we have in Sri Lanka? How many? 9, right? So if you get a data set from Sri Lanka and it says Western Province, say number plates, Western Province, um, Uva Province, Southern Province, I don't know, like those provinces, and then you run it. If you get n unique to be 8, this means there's some label missing. Okay, so that's part of the analysis. This returns 49 for this data set. One out of 50 states in the US does not appear in this data set. Therefore, we can conclude that there is one repetition in the state column. There is one repetition. So, one out of 50 states in the US does not appear. Therefore, we can conclude that there is a one repetition in the state column. Similarly, if we run this function on the country column, we get an array with only one element, United States. Immediately, we can see that we don't need to keep the country column at all, because like this is how you drop values. Like previously, we dropped the row ID values because we have the index values already. Now we have 49 labels for the states that will be important for the analysis. But if it is like now, for United States, if you get one unique value, that means the whole data set is about United States. You don't need that value. So if you go and run that for the country, you get one. So you can drop that country column because it is not needed for the analysis. We know it's from United States, right? So that is removing 990 pieces of unnecessary data. So we'll um, drop that. I'll go with conditional. You can drop it like you did in the previous case. Df dot drop. Forgot the code actually. It goes like df. Yeah, the name, whether it's from the horizontal or the vertical axis, and then just drop it. So I can go and drop that column instead of row ID. I put. So I have dropped that unnecessary single column. So when you are doing the analysis, if you get a data set that has, say, particularly unnecessary labels, remove them, because it's not just that information that you are removing large set of other memory cells, because 994 times 9, that's a pretty large number, right? Often we don't want to process the whole dataset and would like to select only a partial dataset whose content satisfy a particular condition. This is probably the most common use case of any data wrangling task. So when you are dealing with, for example, okay, I'll give you an interesting example. Let's say that you are trying to analyze the news sources and the number of times whether a particular word appears during election times. So, for example, let's say protecting Buddhism or some sort of a religious extremist, these things, if you are trying to analyze whether this word appears before an election, you don't need to analyze the whole data set that goes from like full year. You can subset the data set from, first of all, look at the data, like the time frames where a particular election was announced, right? Then from say 2022 to 2001, you can look at the all those 21 years and then see where the elections were announced, and then from there maybe 3 months before, you take subset the data and see the word metrics, whether a particular word appears in that the frequency of the word. So conditional selection is like that. To have a condition, you need to have some idea about the data set. So because we don't need to process the entire data set. But if you want to see whether there's an anomaly of the use, say like Buddhism and maybe some rational content, you may need to look at the entire data set and see where the anomalous points come. And then if you can come up with a value that says they come before an election, particularly now you can see how they appear, then you can actually find that intelligence where this comes and why this is important. Right, we don't want the process to process the whole data set. Probably the most common use case any data wrangling in the context of our data set, think of these common questions that may arise from the daily activities of the business analytics team. So this is the hypothesis that you are doing, like you learned about hypothesis in statistics. So this is your question when you get a data set. First of all, look at this question: what are the average sales and profit figures in California? Then you don't need the other states, you just drop other states and take California only. Which states have the highest and lowest total sales? Okay, to answer this kind of a question, what would you need? Which states have the highest and lowest total sales? What would be the columns that you want? Which states have the highest and lowest total sales? Yes, just two columns would be enough. States and the sales. What consumer segment has the most variance in sales profit? You have to take the data that belongs to a particular set of consumers and then look at the sales and the profit data. So sometimes you can create an index out of sales and profit, maybe some measure, some index, so that you can reduce the dimensions. So again, coming back to the question, have you done principal component analysis, PCA, in multivariate statistics? Done. So what do you do in PCA? What do you do in PCA? You do a dimensionality reduction from the variance between each data axis. So basically in PCA, what you do is you create a column, you create an axis that has the maximum core variance, sorry, minimum covariance, and the direction is the eigenvector of that variance. So for example, if you had four dimension data with dimensionality reduction, PCA would give you three dimensions that have the highest variance but lowest covariance. So that's what happens. Now that, like, if you take sales and profit and try to find out which one describe the data the most, you may need to do first a PCA and then look at the data from backward to remove a certain column. Right, let's go forward. How many of you have done SQL commands? So SQL1 is there. Anyone familiar with SQL? This semester. Okay, so you learn SQL. We'll learn spatial SQL in the next semester. So with is it Postgres SQL? Yeah, are you using Postgres? What is your SQL command base? What is the database that you ASAP? Okay. So so there it's like pretty much like English, like you can write what you need as a subset from the data set. So we have the same command in Python as well with the data frames with pandas. So the next command that you see is creating a subset from ith row and jth column, same thing that we did previously. So I'm just creating this database data frame subset. And have you noticed this command, this backslash? So when you type a backslash in Python, you can actually ask Python to look at the next new line. So in Python, the command execution happens as lines. So first line works, and then the next line. That's why with an indentation, you tell Python that, okay, the next command that you find in the new line belongs to the previous command, right? So it looks at the first command, then go to the new line. If it finds an indentation, then run it as a logic or a dependent command. But when you do the backslash, what happens is Python looks at it and says, okay, we have remaining command portion at the next line. So you can actually neatly organize it. This may be neat in VS Code because you can't see the full screen. You can just put them and organize them in order. Now here, this backslash, what it has done is data frame subset is equal to the location. So you have the range and then the names. So you can type it like that, and then you get the subset, right? So let's go forward. You get this, right? Now if we just want to know the records with sales higher than this, basically we have done this, so I'm just typing this for the sake of going forward, because we have done this previously in the previous class as well. It's a Boolean logic. So you have true, but in order to get this subset, like the true values, you have to put this inside the data frame again. I think that will come in the next part. So this is just the Boolean operation. So you have to subset that Boolean, like you have the data frame subset, and then apply the logic and then say to the Python that I need the true values of this. So you can write different commands, or you can type if you want this here. Now this is just a Boolean matrix. If you type this, then all the things that are true would come. If you say not, okay, you have to type it the other way around. Can I think it works if you type this. It should work. Where is this problem? Okay. Input type problem. To convert it. Okay, I don't want to go there. Just if you want to have the other way around, you can say this. Right? Anyway, I don't want to go into the command details because you have done this already. Now again, if you type the unique values here, uh, you should get it. If you go and check the unique command for this subset, you can get the number of unique values. You should get it in unique. Okay, this is created not as a data frame, so right, it's fine. So this is actually a Boolean data frame taking as an index to get the original data frame subset. Let's go further. For entries that do not involve California, we kind of nest the logic. Again, as I told you, the backslash is important here because you can just type the command as you like. It can go level by level. It's a bit difficult to type like this. You can just type this command. So df subset sales is greater than 100, and because and logic works both ways, and the subset state is not California. So I hope you remember that this exclamation mark indicates not. Yeah, this is the code. It's not. So exclamation mark. So remove all the California. That if you say equals to California, double equal because it's a Boolean logic, then all the things related to California will come up. Right. and not California is here. uh, DF subset state, not California. It pops up with this logic. It should not be like that. This thing should go up. California. Let's see. Second. This should not come. It works. This, I have to look at that why it happens. Okay, let's see if it works. First conditional expression simply matches the entries in the state column. Okay, but both logic should work in AND operator. Let's let's run the command backward because I think and works here as a join operator. So let's run this here instead of. So the first command goes with the state. So this California thing should not come. Okay, still California comes. Uh, I'll look into that. Let's go forward. Okay. Okay, I think that I have to look at the parenthesis command is the problem. This, I think now it should work because when I run the command, it didn't take them as two separate Boolean operations because I didn't put parentheses. So when I run the command again, you should not see California because uh, when when I run the first Boolean command, I said AND logic. So what happened was the AND operation was not properly executed because the uh, this one was not taken as a single operation. So now with the parentheses, this one gives a true or false logic, and this one gives a true or false logic. So then it goes in the AND operation, then the subset happens. So you don't see California again. So make sure that you put the parentheses in both cases. Right. So let's go. There is no limit to how complex a conditional you can build using individual expressions, logical and or operations. It is advisable to create intermediate Boolean data frame with limited conditional expressions because you are the not you are like you are the creator of the code, but you will not be the person who will be looking at the code again and again. And next time when you're looking at it, you may not know why you apply the particular logic. So, best to keep simple logical structures and run them. So, let's. Uh, this is P2, right? So, I'm working with P2. I don't want to create a new one. So, the next one is with NumPy arrays. I'm going to create May 29 P3. May 29 P3. I hope that this session would help you to work with your assignment, which has some degree of data wrangling required. using different subsetting. Okay, the I have put the question assignment on the Moodle. So if you look at them, look at the just type it, import numpy as np, uh, np.random seed, keep this as 42 because we will have the same number set if we are going to create random numbers. Okay, import pandas. I'm going to import upfront, and I'm going to create this data frame that has matrix data column. Let's see. So I have created a data frame. Ah, right. Now it should work. So I have created a data frame using numpy matrix that I created, matrix that belongs 22 to 60, that those values. And from the matrix data, I created a data frame, and index came from the row labels, and columns came from column headings. So row labels. So basically, what happens here is I create row numbers, set up row numbers as a NumPy matrix, and the matrix has what, three values: 22, 60, 140. Then you have semicolon, 42, 70, 148, semicolon. So 3 by 3, like 3333 data set. And then I say row labels. I gave five row labels, because it's in the row you count the number of semicolons plus one. So 1, 2, 3, 4 plus one, that many row labels are there. Then column headings, I have three because I wanted three data sets, like three attributes. So then I create the data frame. Remember, because these are very basic things, and if you forget what you are doing here, then whatever you do at the back will not be how to say fruitful, because you don't know where you have started, because these things are fixed. You are creating a matrix that contains three and five rows and three columns, like five rows and three columns. So row labels, you should have five row labels. And if by any chance if you forget to give this, you get this error. And if you read the error, shape of pass values is 53, indices imply 43, which means you have forgotten one row value. So remember, always try to change this and see what the error is, because uh, you never know. Now it should work, because I have added a new row label. Now it is the same, right? And I have given coming back to the code, data frame is created with pandas dot data frame command. So the input comes as first as a matrix, then index, number of index, the labels, then the column. So pd dot data frame goes as matrix, row labels, column labels, and then just it ends there, and then print the data frame is this. So this has nothing to do with the work itself. If you run this, it will work. This is just to make sure that the it looks nice. That's all. Right. Let's go forward. This is what we get. Okay. After resetting index separate, let's see what will happen here, and then talk about the command set. Here, what? when you put it n after resetting index 35 separator this equals to the spacing, you have what do you have? Oh my god, the batteries. Is it working? Ah, okay. Charge. Right. So I have reset the index values. Just forget about this one. Doesn't have any value. So df1 reset index means I have changed the index back to the 0, 1, 2, 3, 4 in Python. Remember when we created the matrix to data frame last time, we gave an index equals, here we told what index is, right? So that's what we have done, we resetting the index. So it goes back to 0 to 1. Okay, let's go quickly. So you can say reset and index drop to true. If you do that, the difference would be, look at what happens. Now I have dropped A, B, C, D, E, and instead of that I just kept the index 0, 1, 2, 3, 4. Drop true. Right, let's go further quickly. Okay, so this is how you actually label data. Data wrangling is part of creation of data for machine learning and deep learning applications. So data wrangling is very important in your research. Now what happens here is I have now adding new column profession. I'm going to add a new column profession where student, teacher, engineer, doctor, nurse is the profession, and I'm going to split it. So let's see what will happen. So split command works student, teacher, engineer, doctor, nurse. Okay, so it goes as splitting into 5. Now the same thing, I'll show you what happens if I say, instead of this, if I need to label them, okay, I'll just create a new thing and show you what will happen if you want to label it. Say for example, you need to label this as 1, 1, 0. It can be yes or no something, right? So this is your matrix that you got as a label. If you say that new label is this, so this is your command, like yes, no, yes, yes, no, yes, no, something, and this is what you get. So when you want to train the data set, it can be logistic regression, it can be any sort of labeling. You can have the string value and then say that this is the labeling. So it creates the data frame as is. Okay. So after that, you have label data. You can go for supervised machine learning, anything that you like. Okay. So let's. So you use just the string and then splitting it. Okay, so now set the version as index. So changing the index is also something that you can work on. So when you do this, now you have changed the profession. So remember how we started it, okay? Now data comes in this way. If it is a IoT sensor, if it is even in a data extraction process, like from web scraping, you get data like this, just as a raw text file with this much of data and this much of labels and whatever. So you start from here. So if you look at just the numpy matrix, if you just look at the numpy matrix here, see what you have got. Okay, so this is what you had. Start from here. Now you are here. You create a Python data frame, pandas data frame with indexes, labels. You change the data into different hierarchy levels, the first level hierarchy. So this is what you have right now. Okay, so that's what we call data wrangling, starting from the raw data all the way up to process data. Okay, so okay, let's go to the group by. There are several options with group by. Grouping is this hierarchical indexing. So splitting the data into groups based on some criteria, applying a function to each group independently, combining the results into data structures. So a group by can be something like, say, I measure the weight of all your classmates, your batchmates, and the height. Then I want to group by, say, a particular weight and a particular height. This is the Boolean logic, the criteria that I'm going to use. We talked about them in data wrangling dynamics, aggregation, transformation, and filtration. So aggregation, compute summary statistics to understand the anomalies and etc. Transformation, performing the Z transformation or minimum maximum transformation. Filling missing data with a value. Filtration happens with logic, discard few groups, group wise computation, true or false logic. So let's group by. We have the superstore dataset. I'm going to start with a new one. So I'm going to name it as P3. I'm going to upload them anyway, but please follow along with what I'm doing. We have another 15 minutes or something. So I'm going to rename this May 29 P4. Okay. Right. So I'm going to import NumPy as np and import pandas as pd. Then I have the data set anyway, so I don't want to worry about it. Right. So this is what we had. We removed the row ID previously. So anyways, 5 rows and 21 columns. This is what we had. Create a 10 record subset using the following command. So let's look at the command first before running it. I'm going to copy this to my Jupyter. So location I for I know I for the rows and j for the columns, right? So from I for I in range, let's say I in range 1 to 10. What do we get? Okay, so what do we get is if you type I in range 10, it start from 0. It types from 0, 1, 2, 3, 4, all the way up to 9, because you have range 10 that goes from the last one is not printed. So when you have the range, it goes from 0 to 9 with the subset of this 0 to 9 and the values. So we have the subset of 10 data sets, 0 to 9. Okay. Now, next thing, create pandas data frame using group by method as follows. Let's see what will happen when you uh, when you do this by state. So we have a subset. This is a subset that contains 10 rows and 3 columns, and then I'm going to group by state. So by the command group by, what I do is I'm creating a new hierarchy that says I want a subset of within the sub. I need a different subset that says one level of hierarchy belongs to the state. So it's like grouping all these things in the name of state. So you get this object command if you want to see this is a data frame object. See, group by, it's a core group by generic data frame group by object. So this is what has happened, and it asks us to print the. Now the data is grouped by the state. So if you print this, let's see what will happen. You should get group by state mean value. So which means if you look at the states, how many unique states were there? 49, right? So you should get the mean group by. So there were 49 in the original data set. So we took a subset. In the subset, you have 3 states, and then the mean was selected from the 3 states unique values. This is very, very powerful, because if you want to do this in Excel, you have to run filter by command, or you need to create a pivot table. You need to create pivot table and see how each unique value gets the mean and the standard deviation and all. But the good thing with Python is all these commands can be run in single go. Like you just type everything and then run it. Everything will be there, and the last value will be there within like 1-2 seconds. So all of you are doing data science as decision sciences in your major study. So the primary objective of modern data science, modern decision science, is to make sure that the time between decisions are reduced. So optimization and how you come up with a certain data grouping, it doesn't matter how you do it, but you have to make sure that it happens in a fraction of second. Otherwise, say in I watching IPL matches, or like the cricket matches these days, and football matches, rugby matches, and these other sports. So the what you call the strategic timeout is within 3 minutes or 4 minutes in some cases, and in rugby also we have some strategic timeout. So to get the decision, you need to come up with the analysis in like fraction of seconds. If you have the player like positioning, the run rates, and also who is performing and how many overs are left, you need to have that particular data set prepared in like matter of 2-3 seconds, so that in the strategic timeout you need to tell your captain what to do. So this is how you come up with these decisions. If you like, it's okay to do this in Excel, like it will take but 2 hours 3 hours and the match will be over when you come up with the solution. So that's why they banned this. I think Tom Mood, who is it? I forgot who did it, but we used to keep some sort of a paper written something on the dressing room to show that this is the decision that we have taken. So the time taken between decisions need to be reduced as much as possible. So this is what the data wrangling in Python gives you. There are other software like SPSS and other places where like this process mining tool is there. It will give you very powerful insights in seconds. So you can actually go and do other stuff of calculations as well. Now this is a generic Python group by data frame. It doesn't have any. It's just a virtual space. So if you run this on again on that particular group by object, you can get all sorts of values. Now here I got the summation of the sales for the particular groups again. Right? Those who are trading in this Binance and other Bitcoin and these things, you know that they change. There's a demand cycle and supply cycle in a very small span. So between those cycles, you do the trading. So you need to know the options, what sort of options you have, who is going to buy, who is going to sell. Um, the decisions come in seconds. So let's go and data frame by state describe the location for California. Once you create this data, look at what has happened. I have created the subset and I have created this generic data frame object by putting group by command. Group by state. After that, everything that I did was on that object. So this by state is a group by object. By state is a group by pandas for group by object, and that has been used with all these calculations, and then I could easily do it as a description for California. If I change it for Florida, I get the Florida. So, like, it's very difficult to explain it in terms of the large data set. So you can go one by one for each category when you create this data group by object. Okay, let's go further. Um, and this one is also very interesting. So this is actually subsetting the data set with a group by object. This time I'm grouping it by shipping mode, and I'm then describing it. Then I'm going to the location from, because when it comes to ship mode, you have second class and standard class separately. Like in the case of, for example, um, in a cricket match, let's say you are grouping by the bowler or the I would say if, whether it's fast bowling or spin or left arm spin, say spin, then you have left arm spinners, leg spinners, Chinaman, different sectors. Then you can see how your players have scored under different threat level. Like, have you heard that Indian players are like weak for the left arm spinners? So these kind of analysis come from this. So you can identify the number of runs scored against each level, the deviation, the number of wickets. So this analysis comes like this. You group by a particular order and then group by or identify the analysis separately. Okay, so I think we have limited time on all these things. Like, okay, detecting outliers is anyway a new subject. Handling missing values is a entirely new subject part. So I'm doing it next week. So after doing this, I'll upload this book for you as well. Anyway, I'll upload the book partly up to the outliers and handling missing values. This part, that is this section, I'll upload to the Moodle. So please go through that and see whether you can use these concepts for your data set, for your assignment. Because I haven't started Python when I distributed the assignment, I'll extend the deadline. I'll open the deadline from this week to the not next week Monday, to the Monday afterwards. So that is an individual assignment for that for the from the Kaggle dataset. You have a group submission as well. So the group submission will be from a dataset that I give you, I'll give you the data set, and you have to come up with the presentation as a group to show what sort of problems that you found, what were the techniques that you used to come up with solutions to those particular problems, and your final data set. You have to show, like, describe the data set and all. You need to submit them as IPy notebooks, and you can be creative with your presentation. I don't want you to be people who are just doing Excel or PowerPoint. You can use Python as, notebooks as a presentation markdown, or you can use R. I don't care how you do it, but I prefer if you are doing Python, because the industry requirement is Python these days. So it's better if you can do it. So that will be your group assignment, which will come not in the coming Monday, the Monday next Monday. That is, I think, the last part of it. So you have R assignment, you have done that, the Python assignment, which is with the Kaggle dataset, the group assignment, and then there will be a final assignment using web scraping. So Python web scraping, and then data wrangling. So these four assignments will be your continuous assessments. I'll try to mark the first one as soon as possible before your final one, but I can't guarantee. But usually I've seen people doing well in this particular subject, because it's pretty easy to understand, and only thing that you require is your hands-on experience. If you learn how to work through, like, now, minimize your workflow and maximize the way that you use them. So for example, now you have learned R and Python. So be experts in R and Python. Try to be experts by using it again and again for everyday life. Like, for if you have an Excel sheet, just try to use Python to do the analysis back and forth, to see how you can use it, and be, versatile in both of. So you need R, Python, and Excel. If you learn these three, I think you have a good base to do data analysis and data science for the future work. Learning other things will become easy. Like, you haven't learned C, right? C plus plus, C, those things you haven't learned. So I started programming with C. So like, we had quite a lot of challenges in data structures, and like, in C you have pointers and functions. It's a linear programming, so it's difficult to, learn. C is a bit tough to learn. So, but Python is, it's pretty much like English. If you learn it, and if you think in Python, it's very easy to understand, and you have a lot of good IDEs to work with, unlike C. So but try to see what are the questions that you may have to answer, try to find out the solutions to them. Okay, so I'm going to stop here. I will start from detecting outliers and handling missing values next week. And I will open the submission for the assignment from today for 2 weeks. So you have 2 weeks from here. Okay, so you can leave. I will upload this recording to the Moodle as well, but I don't know whether you are watching them or not. Do I need to upload this? Okay, I'll upload it with the voice separate.